converting into motion. Actually, it will take an input. The actuators, how we are defining actuators, the actuators are taking an input of electrical energy, hydraulic energy, pneumatic energy. They are converting into motion. It may be angular motion or it may be linear motion. And it is a device that makes something to move. Good example is piston and cylinder. Okay. And types of actuators: electrical actuators, electric motors, DC servo motors, AC motors, stepper motors, solenoid valves, and hydraulic piston and cylinder, pump. Okay, turbine. Pneumatic actuators are piston, cylinder, and pneumatic motor. And I'll go the basics because today I am designing by the software the mechatronic system or industrial automation, so that some basics are required. So the valves, I am using a direction control valve 2x2, 3x2, 4x2, 5x2, because in each port there are 2 holes, so that 2x2. Here 1, 2, 3. There are 3 ports in each position. There are 2 positions, first and second, so that it is called 3x2. Here there are 4 holes for 2 positions, 4x2. Here 5 holes. There are 2 positions, 5x2. So this is the internal section of 4x2. There are 4 P, T, A, B. There are 4 holes. There are 2 positions. The first position, the pressure oil or pressure air goes from P to B, and the low pressure oil or air comes from A to T. And in this case, when you press the push button or a spool, then the oil goes, instead of B position, it goes to the A position, and unpressurized oil comes from B to T. So that this is the internal cross section of 4x2 wall. I'll show the animations. So pneumatic systems, then there is a mechatronic system. Just quickly, I'll show first the some PPTs. The single acting cylinder. This is 3x2 wall, and in a single acting cylinder there is a spring. Due to spring return, it comes back. So now it is a double acting cylinder, 5x2 wall. So in first position, the piston moves extending. In second position, the piston is retracting. And here, usually the retracting velocity is greater than extending velocity, because the rod side, the area is less. So that Q is equal to AV, V equal to Q by A. So that retracting velocity is always greater than extending velocity. So this is the pilot operated double acting cylinder. I'll show how to build, and with animations I'll show. Okay, in the pneumatics only the walls are very important: 5x2, 3x2, push button, spring return, and piston and cylinder. And this is nothing but what compressor is required. And FRL unit in the pneumatic, the pneumatic and electro-pneumatics, we are using FRL unit. FRL means what? Filter the dust particles, regulating the pressure, and lubricating to the air. So FRL unit is very important in the pneumatic system. It may be electro-pneumatics or it may be pneumatics. And the flow control valve. Okay, flow control valve, I can control the velocity of the piston and cylinder. And this is what AND gate, especially in the press operation, we are using AND gate. Unless until S1 and S2 we are not pressing, the press is not coming downward direction. So that this is the dual pressure valve and the logical AND. Because till today in the painting industry and chocolate industry, they are using pure pneumatic automation. They are not using even electro-pneumatic and mechatronics, because there is a electrical circuit. There is a problem in the painting industry and chocolate industry. Till today they are using automation, industrial automation, using a pure mechanical, that to hydraulic and pneumatics. And this OR gate. Okay, I'll show all the animations. So these are all the circuits. These PPT I can share with you. Okay, here there are 2 cylinders, sequencing cylinder. A plus means the first cylinder is extending. A minus means first cylinder is retracting. B plus is nothing but first cylinder is extending. B minus means second cylinder is retracting. You can set any sequence, and here the how it is automatically working I'll show. So these are all what different types of circuits in the pneumatics. You can build any logic you can build, 3-cylinder, 4-cylinder, and sequence AC or AB, whatever your sequencing you required, you can design. So these are all these PP sensors, available sensors. There is a proximity sensor and supply and DC volt. And for sensor, there is a DC volt is required, 24 volt DC volt is required for a sensor. If you use more voltage, it will burn. And switch are nothing but these are normally closed switch, normally open switch, and proximity switch. Sensors, capacitive sensor, inductive, magnetic sensor. And you can write any text here. You can write any text here. Okay, working of double acting cylinder. You can write any text. So I'm teaching, not only I'm sharing the knowledge of industrial automation, I'm sharing the knowledge of how to use a software, because you can use this is as a virtual lab for mechatronics. Okay, so all animations and any kind of experiment you can do, any 100 experiment you can do on this software. This software is really available, and if you practice it, and definitely double acting cylinder, working of double acting cylinder. So you can use any font bold, suppose, otherwise 16. Okay, working of double acting, you can anywhere, fine. So here the cylinders are available, single acting, double acting, double acting cylinders are available, and these are all sensors. And supplies, supply is the thing, but the power pack is required, compressor, FRL unit. Okay, so I'll show quickly. I'll take a one system, double acting cylinder. I'll pick a double acting cylinder, and to control the direction of this double acting cylinder, there is a valve is required, so that you can see the valves. Okay, so valves are here. This is 5 by 2. Usually in the pneumatic 5 by 2 I am using. In a hydraulic 4 by 2 we are using. Suppose this hose pipes connections. Okay, pipe connections. And here I can first I'll show by manually, then I'll show by automatically. Okay, and there's a compressor is required. Okay, and FRL unit is required. FRL unit. Okay, input to the FRL unit, and here I'll attach a muffler. That is a muffler or a exhaust system, because it reduces the noise actually. Okay, so muffler. This is the one pneumatic system. The first I'll show by how you are controlling by manual. Okay. Now if I press this animation, and it will show the velocity also. Velocity we can calculate. Velocity also we can calculate. So sensing element, cushioning parameters, and here many parameters you can set. Velocity, suppose if I make a velocity is on, extending velocity is 0.7, otherwise I'll reduce the, then automatically instead of 1000 I'll go for 1, suppose. So velocity is 0.05, maximum is 0.0, slightly varying, and retracting velocity is always higher, extending velocity is always lower. So like this, manually I can control. So usually in the industry, they are using a pilot operated. Just quickly, I'll show what is meant by pilot operated. Because for a complicated a 3 by 2 valve is required. 3 by 2. Here the walls are available 5 by 2. Here this is a 3 by 2, and one more is called 3 by 2. These are called So this is 3 by 2. So this valve, instead of using directly, I can use through what? By using pilot. These two are the, this is now 5 by 2 pilot operated valve. So if I push this, okay, so air has to move now. Fine. Slightly I'll increase the velocity. Instead of 1 flow, there is a discharge 10. For okay, for retracting, it is not retracting because it is on. So this position is on, it holds. It has, you have to make off. Even if I press this, it is not working because you have to make it off. So then you make it on. Instead of this, I go for spring return. All options are available in this software. So this is a spring return. Now just you press it and this will be off, but remaining this is on. And then you press it. Now if you press it, okay, this is what manually operated. But what I want now automatically. That is called automation. Automation means very lesser the interventions of human. So now I'll go for this sensors. I'll attach a sensors here. So say name, you can give any name, S1 and S2. First sensor at the starting of the piston. Second sensor is at the end of the piston. S1 and S2. So now S1 and S2 are what? The magnetic sensors, because piston is also magnetic. S1 and S2 are the sensors. So, and especially I am using now pneumatic sensors. I am not using electrical sensors. Okay, in the electro-pneumatics, I am using electrical sensors. Now I am using pneumatic contact type of pneumatic sensors like this, S1 and S2, contact type of roller, or it is called a limit switch. This, when this S1 is on, the air goes to here. So it will push this, the name I'll give S1. When it reaches to S2, now the air has to push to this valve 3 by 2. I'll write S2. Now it is automatic. Now this is called a sort of automation. You see the animation now. Animation. And before that, I'll give the some exhaust here also, because it reduces the noise. And it's a complete figure. Now automatically it has started. I can use one control master button also below. I can use like this. How to control the one master button or master delete. One more push button you can use here. That is a on and off. This is for on and off. You can use on and off. Okay. So here also I can use, but I am not using here spring return. I am using mechanically push button. I am not using, when this is the start button. If you press this, then only entire system will start. If you off it, the entire system will be off. Now entire system is on, off. Even the blue line indicates the pressure air. Pressure air goes to, it stuck here. Pressure goes here and it stuck here, this side. Pressure air goes to stuck here. If, when I make this is on button, then the entire thing will be on automatically. This is called automation, pneumatic automation. Here still some 20% industry they are using pneumatic. Pneumatic automation is tougher than electro-pneumatics and mechatronic system. So I can off this, the entire thing will be off. Now quickly you understood this is a 5 by 2 pilot operated, and this is a 3 by 2 spring return wall, 3 by 2 spring return wall. This is a 3 by 2 non-spring return wall. You have to operate 2 times. For on also you can operate, off also. This is the piston and cylinder. So this is what the pneumatic system, and this is a automatically, this also sort of pneumatic automation. And here also you can go for AND gate. Especially I have told good example is a press machine, 2 buttons you are applying, then only if you press both the buttons, then the RAM will be come down. So OR button, OR gate, OR logic, you can use any type of logic in the pneumatics, but it is a tougher and only 20% of the industry they are using, like paint industry, chocolate industry, okay, chemical industries. But other 80% industry they are using electro-pneumatics and PLC based industry. So that now I'll go to electro-pneumatic system. Electro-pneumatic system. Already I showed. So my any type of circuits, and I'll share the PPTs. Once again, if you want, I'll show. Okay, so I'll start now electro-pneumatic. I'll start electro-pneumatic. Before the electro-pneumatic, this is very important. The input, this is the input, the output. Now it is out. This is the output. This is the output. This is the input. So here, when you are giving an input, the definitely what happens? The armature comes contact. Now it is, this is on. When it comes and contact here, this is on. Now there are two outputs. So now this in output is on, or if you give an input and this output will be on. So that this is the relay. Relay is an electrically operated switch. It consists of a set of input terminals for a single or a multiple control signals and a set of operating contact terminals. Very a logic you can use a relay. So that you should have a knowledge of relay for a electro-pneumatic. So now these are the many circuits I'll show. I'll build and OR and latching. What is a latching circuit? This OR without relay, with relay, and latching. Latching is a very important concept. And on delay timer, off delay timer. Especially you see here on delay means just you have a look. On delay means if I start suppose I'll give one example, good example. In the on delay, suppose grinding machine and lubricant pump is there. Only one switch. You start one switch. The lubricant pump will start. After 5 minutes or after 4 minutes, the grinding machine will start. Because the logic behind is the sufficient lubricant has to fall. Then there is no problem for the cutter, for a grinding wheel. Or so that on delay timer you can use in many applications. You can set the time 8 seconds, 4 seconds, 10 seconds, whatever you can set the time. After that time, the second output will start. So off delay timer is a good example is in the car. In the car, especially diesel cars and all, there is a, if you start the engine, then the fan and engine will start immediately. But if you off the engine, the first what happened? The engine will off, but the fan will remains on. The fan will off after whatever the preset time. Say for example, 5 minutes, 4 minutes, 3 minutes, depends upon the capacity of the car and all, number of cylinders. So what is the logic behind? It cools the engine. It cools the engine because next time as soon as we'll start, there is no detonation and knocking. So that off delay timer and on delay timer depend upon the application you are using. And that is called many circuits I have developed. I can share the PPTs, and I'll build some electro-pneumatic and pure electrical circuits. I'll show how they are working. Yeah. So these are all circuits you can develop. Any n number of circuits, 2 cylinder, 3 cylinder, logic A plus A minus. A minus means the piston is retracting. C plus means third piston is extending. C minus means third piston is retracting. B minus means second piston is retracting. AB plus in the bracket means what? At a time, simultaneously. In the bracket means at a time. A and B at a time they have to, plus means they have to extend. Okay, A minus and C plus means sequencing. First A minus and then C plus. These are further as sequencing. So these are all electro-pneumatic. Now I'll show through the software how the electro-pneumatic, very interesting electro-pneumatic. Okay, so a very basic electrical knowledge is required. 24 volt and 0 volt, and solenoid valve is output, timer is output, solenoid valve is output, timer is output, counter is also output. Okay, input is our only sensors, and output is required. There is a ground 0 volt. You see here the Y1, Y3, Y2 solenoid valves, and these are all outputs. The outputs are at the end, they require 0 volt, and input from the sensors. So now I'll start my software, Festo software, a new file. Now I'll take a first I'll show how the electrical switches are working. Normally closed switch, normally open switch. Here 24 volt is required, 24 DC volt, 0 volt is required. Correct. So here there is a push button means what? The spring return button. Push button means, suppose first I'll use a dependent switch. Dependent switch means our normal switch. While on also you can apply the force, while off also you can apply the energy or a force. Okay, effort. Suppose this is a dependent switch. I'll use a one bulb. You are understanding? So this is a bulb and just 0 volt because bulb is output. At the end the grounding is required. Now I'll show the animation whenever I'll on. If I press this dependent switch, okay, and the bulb is on. If I make it off, arrow mark indicates there is a on. If I press this, off. If I press this, on. If I press this, okay, I can use a push button. Many application push button is required. So here all the switch is heading. So push button. You can read in the library. So this is a push button. You can go for animation. Push button, as soon as you leave it, it will off. So this is the working of push button. Now I'll go for what is meant by latching. This is a very important concept, latching. Latching is a very interesting thing. Suppose the computer is there in the latching. If you start the computer, then the computer will start with the same button. If anybody will come and suppose there's a FEA analysis you are doing, the 4 hours is required to get the answer. Suppose your discretized elements are more than 10 lakhs, 20 lakhs, 30 lakhs, then it requires a 2 hours, 3 hours time. If you start and if you go somewhere, if somebody will come and off your computer, then the entire thing will be goes. So that even if you press that button, it should not off. Then how to make it off? So it is a very logical one. By using relay. Relay is required. Now I'll show this bulb. First of all, I'll show I can on and off this bulb by relay also. This is a direct method. Now how to use a relay? That is a very important. Electro-pneumatic means you should know working of relay. This is a symbol of relay. This is a symbol of relay. Okay. So now I'll use the dependent switch. This is a dependent switch. You can make it straight. Okay. This is you write a name R, any name you can give. R is a relay. Now as soon as you'll press, the R is on, the relay is on. Your relay has one input and multiple outputs. So I'll take output, make a switch. Okay, so I'll write R, make a switch, write R, because same name you have to give. Then I'll interface the bulb. Now if you press this, this is the indirect method. Through relay you are using the output. If you off it, just you see that if an R and R, logically when this R, but this switch as you are taking a 24 volt here. So by using relay, you are using the output, or you are interfacing the output by using relay. Many times the relay, without relay you cannot do. In this case, okay, without relay also you can on the bulb. Now I'll go for latching. So latching is very interesting thing. Suppose here I'll use this R in the parallel. Means what? Just you see that first half of the latching I am showing. Latching is the thing, but what? Suppose your window is there, you are latched from inside. Okay, from the outside somebody is trying to closing. It is not closing from the outside if you are latched. But how to close? But only inside you have to remove the latch. Okay, so like this. Here you see here R, same I used in the parallel. Now if I press this, R is on. Here directly R is on. This also switch is closed. The current is coming from both the direction, from here and here. If I make it off, still R is on. I'll show in the better manner by using a bulb. Now you are understanding. In the bulb, and use a make a switch, one more R. Already I told you can take any output from the relay, n number of output, but a single input. So now it is R. Same name you have to give. Here there is a bulb. Now here output is required 0 volt. If you are not giving a 0 volt, it is not on. Suppose you are not given, suppose, and if you go for this, it is the bulb is not on. So that you have to complete the circuit now, and here you have to press, and even you make it off, but still it is on. It is called latching. It is called latching. Even if you make it off, the means, but how to make it off now? How to make it the bulb should be off. So that one more, the switch is you are using, that is called normally closed switch. This is normally open switch. Normally open switch. Now you have to use the normally closed. Here breaker switch. You have to use a breaker switch. So initially it is closed. Otherwise you can use a push button, normally closed push button. So this is a push button, normally closed push button. Okay, so this switch is for off. Okay, you can write also text. This is the off button. This is, you can make it off. You can write text anywhere. This is off, and the copy you can make it copy and paste also. This is what on. On. So this is on and off. This is a R is a relay. This is output. Okay. So now you see here, if I make it the main switch, the system is on. Even main switch is off, but still output is on. But how to make it off? You have to press this. Just you break it and leave it. Spring return automatically. You off it. How to start? Once again, you start from this button only. Once again, you start from this button only. So like this, this is a latching is very, very important. Latching. This is called latching concept. The relay. Now you'll come to know that how the relay is working, how the latching circuit is working, how the normally open switch and normally closed switch. Okay. Now I'll use a piston and cylinder. Then pneumatic cylinder already you have seen. Pneumatic cylinder. Now what I'll do, I'll interface the electrical ladder or electrical circuit to the pneumatic circuit. Okay, this is so first I required 4 double acting cylinder. This is called double acting cylinder, and in a pneumatic I am using normally 5/2. Okay, 2 exhausts in a pneumatic, because air is what a light, so that 2 exhausts are required. Back, it should not produce the back pressure. So that in a hydraulic you are using 4/2, and here compulsory I'll use a solenoid valve. The solenoid valve, there is a coil inside. There is a coil, solenoid valve. I'll write here A plus. A plus means what? Piston is extending. A minus means what? The piston is retracting. I can give Y1, Y2 any name, but standard is A plus and A minus. Okay. And here the compressor is required and FRL unit is required. The FRL filter, regulator, I can use in both pneumatic, and wherever compressor is there, FRL unit comes into the picture. You can regulate the pressure also. And here I'll fix the sensors S1 and S2. This is called semi mechatronics also, semi automation also. Okay. And here I'll write, S1 should be at the beginning of the piston, S2 should be at the end of the piston. Why I'm writing 100? I can fix at the center also. 50-50 means the sensor will be at only at the 50, length of 50 of the piston will go back at the 50 only. Okay, so that magnetic sensors by cello tape you can fix S1 and S2 easily, and A plus and A minus. Now I'll develop a electrical ladder or electrical logic circuit. So that electrical logic circuit, first I need what? 24 volt DC. So I'll write here 24 volt and 0 volt. Okay. And then S1, the sensor, make a switch, I'll write S1. Make a switch, I'll write S1. So here I'll write a S1. S1 is a sensor. S1 is already closed. Why automatically closed? Because here the S1 is on. The piston and sensor is producing 24 volts, so that automatically closed. When S1 is on, the solenoid valve A plus is a solenoid valve. Okay, A plus is a solenoid valve. This is a symbol of solenoid valve. Here you see here valve solenoid. Here there is a valve solenoid. So valve solenoid. Here there is a valve solenoid. So here I'll write A plus. Now I am using without relay. Further I'll show how to use a relay here. Directly I am using A plus. When S1 is on, the logic is A plus should be on. A plus should be on means this position of the valve is on, so automatically the piston will move. Piston will extending. And when S2, so make a switch. So one more solenoid valve is required. So make a switch S2. When S2 is required, when S2 is on, then the A minus solenoid valve should on. This is A minus. Okay. So this is the electrical logic. Now practically in a wire, there is the one wire from S1 to A plus, one more wire from S2 to A minus, and S1 sensor are required. Sensor are also passive elements. They require 24 volt and 0 volt. I'll show later. So here now the system has to work. I'll start the animation because it goes up to S2. Okay, I can reduce the flow. Instead of 1000 liter per minute, he has mentioned the unit also, liter per minute, and pressure is megapascal. Okay. So now, so if I change the position of the S2, if I change the position of instead of 50, I'll go for 100. Then at the end of the piston, the sensor, now full stroke. Automatically, this is a industrial automation or a mechatronics. So everything, you can use a one master control in your hand. Suppose I need a one master control. Suppose I can mention here the start button, that is called a determinant switch. You can use unless until you are not starting this switch or making on, the system is not on. So this is the start button you can use. Okay, you can use the start button, and you can write a text also. This is the, there's no need to write here, but for our understanding purpose, start. Okay, start button. Now S1 is the sensor, A plus is output solenoid valve. Okay. Now system has not started. I'll make it start. Then the entire system will start. I can increase or decrease the velocity by changing the what? By changing the discharge of a flow of a air. So it increases the velocity. Okay, this is called electro-pneumatic, comes under industrial automation. Next is very interesting. So timer, I have to use a timer. So in this case, or otherwise same thing, I can use a relay. I can use a relay. How to operate this system by using relay? Because here I have not used a relay. So quickly I'll show within a minute. I'll show by using relay. You can move like this. Okay. I'm showing all the commands also. Parallelly, I'm sharing my knowledge about the software also. So now I can use a relay. You know the symbol of the relay is a rectangle block here. Relay is a rectangle block. So I can use a relay because further, if you use a relay is better, because some programs without relay, you can, some logic without relay, you cannot do anything. So that you should familiar with relay. R1, you can give any name, no problem. R1, when R1 is on, make a switch. logic switch. This is called logic switch, not a physical switch. Now, whatever I am showing this now, R1 is what? Logic switch. So here, R1, I am taking out output from the relay R1, R1 to what? Solenoid valve. So now I am not using the solenoid valve directly. Through relay, I am using the solenoid valve. The load, whatever the load will come on the solenoid valve is gradually and safety wise, so that better way we have to use a relay. Okay, A plus. And suppose second without relay. And now you can use directly second A minus solenoid I use without relay, A plus is with relay, so that you see here how it is working. Relay you can use. Second also you can use a relay. Okay, I showed now by using relay how to interface the relay. Now next is very interesting, on delay timer. Suppose when the piston goes to S2, it has to stop for, say for example 10 seconds, because for drilling operation or reaming operation, some operation it has to stop, and after the completion of work automatically it has to go back S1. And S1 also you can give a on delay timer, because second part you have to insert, so that you can use a timer both the sides or only one side. So that now I'll show here when S1 okay, directly the one S1 first I'll show when it is at S1, A plus should occur, or event should occur A plus directly without any delay. I'll keep a delay when it reaches to S2. When it reaches to S2, there is a delay. So that here I'll use a what? Timer. Which timer? On delay timer. I have to use a on delay timer. Okay. So here the on delay timers are available. Relay with on delay. You can see in the library relay with on delay timer. When it reaches to S2, that is a relay as well as on delay timer. On delay timer. Now you can set the time. Suppose the timer is T1, or it may be T, or it may be T2. Suppose T1 is a timer. Now you can set the timing. Now it's a 5 second. You can set 4 second. When it reaches to S2, 4 second, and after 4 second, the logical switch has to, there's a make a switch. Logical switch has to on. That is the name of this switch is T1. Name of this switch is T1. Now then A minus. You see here interesting how this down system is working. Okay, so now A minus double, it shows the you are given both the names, so that it should be A plus. It is showing all the error also. Okay, it is easy to. Okay, I'll start. It goes and it stops for how many seconds? Because you are set a 4 second. Okay, so like this you can set a timer. Suppose I can reduce the velocity, instead of 1000 I can go for 10. Second, it comes back. Suppose I can put a one more timer at S1 also. When here, so I can use one more timer at the S1. When it comes to S1 also, it has to stop. Okay, one more what timer I am using here. So one more on delay timer. It may be 2 seconds or 3 seconds. You can different time also. Suppose here I'll set 5 seconds, and here I'll set 3 seconds. And name I have to give here. There is a T1. Okay, and here I'll give the time is T2. You can change the name at any moment. T2. Here also switch is T2. And here when T1 is on, T1 will be on after 3 seconds. T1 will be on after 3 seconds, so that this switch should on, logical switch should on after 3 second, name should be T1. And when this switch is closed, then A plus solenoid should on, A plus. Okay, now T1 and T2 are the two timers. You see the circuit. As soon as you will start this button, the current will flow. Already S1 is on. It goes to the timer. The timer starts, but the timer will give the output after 3 seconds. After 3 seconds, this switch is closed, and then A plus is on. Then it goes to S2. When it goes to S2, second timer will on, and when it goes slightly moves from S1, automatically it is off and timer is also off, because slightly when this piston moves, it loses the connection with S1. The S1 is off, then the timer will be automatically off because it loses the supply. So these are called non-retentive type of timers. Okay, retentive types of timers are there. I'll discuss later. So here you see how beautifully this circuit is working. Okay, start. It is the master key, main button. It is in your hand. So there is a delay. First is a 3 second delay, and here there is a 4 second delay. So this is how the timers are working. I hope you understood how the timers are working. Okay. Now there is a one more is a counter. So I'll show one more in the electro-pneumatic. There is a counter, and after that I'll move to the PLC, programmable logic controller. Okay. So in the counter, suppose after 4 times, when it hits 4 times, it has to stop at S1. Automatically it has to stop at S1. So now here I'll remove entire circuit because you can understand in the better manner. So how to use a counter? My application is a very interesting circuit. Suppose I'll write a question first. The question is 4 times A plus and A minus. 4 times A plus and A minus. Okay, then I'll extend the question is like delay. Okay, so it is in my hand, so I'll modify later. This is my question, suppose bold and 16. Okay, so my question is A plus, 4 times A plus and A minus. 4 is what you have to count. So how to use a counter here? The reset button is required counter. So 24 volt, 0 volt. Okay, when S1 is on, make a switch. When S1 is on, you write S1. Then I am not using a relay here. Okay, directly I can use directly without relay, with relay. Sometimes the relay is required. Here relay is not required. So that is a solenoid wall. Here A plus, when S1 is on, my logic, because A plus is here, so that I'll write A plus. When it reaches to S2, it has to count first. It has to count. So when it reaches to S2, make a switch. Okay. So when it reaches to S2, the counter first, counter has to count. Counter electrical counter. He has relay counter. He has mentioned relay with counter. So here there are two inputs. It counts. Okay. And what is this button? R1. R1 is nothing but reset, because counter for next counting reset is required. I'll show without reset what happened, with reset what happened. This is a counter now. This is what counter. This is a counter. Okay. Now it is counting. Now a 5. Okay, you can set any count. Now suppose 4. It will count 4 times. Then the piston comes to 4 times. It has to give the output. Suppose say you give the name is C or any name. C is a counter. When after 4 count, it has to give the output. So make a switch. So this is C output. When this C is output, okay, what I have to do? So it should stop, which the piston should stop. So that I have to use here, there's a normally closed switch. Normally closed switch, the brake switch. It should open when C is on. When C is on. C is on. And when reaches to S2, one more event should happen. One more event should happen. The A minus should on. So A minus should on. A minus. This is A minus. Okay. So just you see that what logic I used. Okay. 1, 2, 3, 4. It has to stop. Now this C is on. The counter is on. So that it is normally closed. This becomes normally open. The current is coming from S1, but normally open, so that A plus. But how to make it on? Now, how to make it on? So that reset button is there. Here you have to reset the counter by manually or by automatically. Initially I'll show by manually. I can use a push button because the very risky in the resetting of a counter. If you hold the counter, counter will dead. Only the reset button should be fraction of second. If you hold this, the reset button, the counter is dead. Counter is dead. So that to reset this by using push button, just you see that 1, 2, 3, 4. It stops. Then you reset it. Okay, reset button is also, I have forgotten the earthing. It is not working now because here 0 volt. You give the 0 volt. One, 2, 3, 4. It stops. Okay, after if you remove the part and then you insert the second part and manually by paddle, by leg paddle, you can reset. By leg paddle, you can reset. Once again, it will start. So this is the reset button. This is a reset button. Once you reset, it starts automatically. Fine. I can, instead of 4, I can go for 3 also. Just you change the counting number 3. So it counts 3 and after 3 it stops. 3. You can set any counter. So this software is very flexible. You can use as a, the students can understand all the concepts, and students can download in the home. They will do fantastic circuits, very complicated circuits they will do. Okay. So now one more thing here, purely automatic, instead of resetting should be by timer. Okay, now I'll interface the timer also. So here I can this reset I can give automatically, because manually I am giving. I know that to remove the part and to insert a part, suppose I required some 3 seconds, so that I'll make a switch. Okay, so this switch by using timer. This reset button should be by using timer, say T. So when the timer will start, when the counter is on, then the timer will start, so that I'll use entire thing should be 100% should be automatic. So I can write here C. When the counter is on, this switch is closed, then the on delay timer will start, and I'll set the on delay timer. Okay, so on delay timer, I'll set the time. If you not give the name, it is not working. Okay, so I have to give that name is T, because this T input, this T input okay, so this T input I have given the reset button T. Now you see here, instead of 5 seconds, I can give of 3 seconds. After 3 seconds, the automatic reset will be, this is a 100% automation. 1, 2, 3. It stops. and after 3 seconds automatic resetting. Manually I am not resetting. 1, 2, 3. Then I have given a delay is 3 seconds. After 3 seconds automatically, suppose I can give a delay is 4 seconds. I can give the delay is 4 seconds. So like this, I can use a counter as well as timer. Both are interlocking. So first initially counter starts the timer off the counter, then counter starts, it makes the timer is off. Okay. So any complicated circuits, I'll show some directly. I have made some circuits yesterday. Okay, I'll show the some important circuits. Okay, 3-cylinder circuits you can build. The question is what? A plus B plus. First cylinder extend, second cylinder extend, third cylinder extend. C minus means third cylinder retracting, second cylinder is retracting, then the first cylinder. This is a logic. You can develop a combination like 3 3 3 3 C3 like 27 circuits you can develop for 3-cylinder. Okay, so I'll go for animation. Just you see that. Same relay I have used, same basics. Fundamentals I have covered. By using these fundamentals, you can create any circuit. Otherwise, you want a bigger manner. And you can set a delay anywhere. Here I have not set a delay. So this is a PLC you have seen, the input model and output model. Input may be 2 or output may be 3 or input may be 10, 20. The Reliance company, the PLC is using inputs are the more than 5,000, 6,000. Outputs are like 10,000. Okay, the size of that PLC will be the room size. So in the lab we are using very small, like half feet by 1/4 feet. The inputs are what 6 inputs and outputs are 6 outputs. Okay. Now the advantage of PLC is the cost effective. Cost is very less nowadays. Flexible and reliable, compact. Okay, you can, and many companies are there: ABB, General Electric, Mitsubishi, Motorola, Panasonic, Rockwell Automation, Schindler Electric, Siemens, Rockwell. Many companies are there. Even Indian companies are also nowadays. Indian companies are also available. Okay, so these are all ladder programming. S1 here, the bulb B is output. B is output. S1 and S2 are the inputs. When S1 is on, B is on. When S2 is on, B is on. This is called OR logic. OR logic. S1 and S2 are the switch inputs or sensors. B is the output. Okay, bulb. So here the below is a both the AND gate. If S1 is on, S2 is off, then bulb is off. If S1 and S2 both are on, then only the bulb is on. Otherwise, the bulb is off. So AND gate. This is the way of writing the program. Okay, and latching already I have told. This is called a latching circuit. When S1 is on, bulb is on. When B, same name, the current is flowing both the side. Even S1 is off, but still bulb is on. When S2 is off, this is called a push button I showed. This is off. This is called a latching. The latching is very, very important. And S1 is normally open switch. S2 is normally closed switch. And here A plus, A minus. A plus is piston is extending when S1, A plus, when S2, A minus. Okay, so this is the PLC programming, ladder programming. Okay, and here A plus, A minus using latching, and here on delay timer already I have explained, and off delay timer I have explained, and retentive timer reset is required, and delay A plus, delay A minus. Okay, so this is A plus when S1 is on, A plus when it goes to S2, the timer will start. When the timer will give the output, then A minus will retracting. So like this, I have developed many logics, okay, by 2 cylinders, not only 1 cylinder, 2 cylinders, sequencing of 2 cylinders, timers, and this is very interesting, complicated. A plus, B minus, and A minus, slightly complicated. And A plus, B plus, delay, AB minus, in the bracket AB minus means at a time, Okay, I'll show the animation now. Okay, after PPT, I'll show the animations. Counting, just now I showed the counting. You can do the same programming in the electro-pneumatic I have showed. You can do the same programming in the PLC also. Okay, and even for a tank processing, the level maintaining of water in the tank S1 and S2, the automatically pump will start. Okay, there is no shortage of water, and so many applications wise, and this is very interesting. The automatic water bottle filling, as well as it is counting how many bottles are counted, and when the bottle and the conveyor, whenever the bottle, the conveyor motor will start, and it will stop when the sensor, then it will fill. You can give the timing, then after the timing it will fill and goes out, and it will fall on the box, and how many boxes are filled, it is showing. So I have written the program, and all the programming are run by software. I have checked, I have highlighted by the software. Okay. So these are all the stamping machine PLC. Here PLC is available. So here PLC is available. Two PLC, you can select anyone. The PLC is required 24 volt and 0 volt. So first I'll give, without 24 volt and 0 volt, it is not starting, because this is also passive element and especially required DC volt, not a AC volt. 24 volt and 0 volt. Here it is showing I1, I2, I3, I4, I5, I6, I7, I8 are the inputs. Q1, Q2, Q3, Q4 are the outputs. In some PLC Q0, it will start from Q0, Q1. In some PLC, it will start from only within 15 minutes. I'll complete. Within 15 minutes, I'll complete the uh, uh, my presentation or my this. Okay. Now I'll use a piston and cylinder. Otherwise, okay, I'll take a piston and cylinder, double acting cylinder, okay. And once again, I'll label S1, I'll label S2, 0, 0, and 100, and 100. And S1 and S2, I'll show clearly how the S1, suppose I'll take an inductive or a magnetic, here magnetic sensor, S1 and S2. So in the sensor, there are 3 wires. The sensor say S1, this is called S2. Okay. So sensor, this is output. The pulse is showing this output. The Q1 I have attached to Q1, say, okay, I1 I have attached to I2. Okay. So 24 volt and 0 volt required for sensor, 24 volt and 0 volt for sensor. And here also the 24 volt and 0 volt, same volt you can use. Okay. This is the sensor S1 and S2. And here the 4x2 is required. This is the valve, you are familiar, 5x2. So I'll use a solenoid valve, 5x2. This is a symbol for solenoid. This is a symbol for solenoid. So I'll write here A plus, and here I'll write A minus. Okay. And here I'll give the supply, compressor, and FRL unit. Okay. Filter, regulating of pressure and lubricating to the air. And here there is a muffler. Okay. Muffler. Fine, A plus and A minus. So solenoids, this is a PLC inputs. I have interfaced inputs from the sensor. Then the output from the PLC to the solenoid valve. So solenoid valve. Here there is a solenoid valve. And here 0 volt is required. And naming is also required. So here A plus, and here A minus. Now, so the PLC, you can see in a one screen, the pneumatic system. I have interfaced the pneumatic system to the PLC and the inputs to the PLC and output of the PLC are solenoid. But it is not working because just it is a black box. You see here S1 is on now because magnetic piston and magnetic sensor, it gives this S1 is the inside part of S1. This sensor is the inside part of S2. It is giving a signal to the PLC, but PLC is a blank now. You have to write a programming. What you have to write? When it is at S1, A plus should on. When the piston is at S2, A minus should on. So that you double click, you will get a ladder programming. I1 is nothing but what? S1. Q1 is nothing but what? A plus. I2 is nothing but S2. Q2 is nothing but A minus. Or the programming is over. You have written the programming. Just you come to here. Now you see that by PLC, by using interfacing of PLC. PLC is very easy compared to pneumatic and electro-pneumatic. Okay, so suppose I'll keep some on delay timer. So at the on delay, so all on delay timers are available. PLC in the below PLC, there is a on delay timers are available here. AND gate, okay, output, off delay, and on off delay, then retentive, then on delay. Here there is a on delay. When it goes to S2, there is a timer. Suppose you can give a 3 second, okay, otherwise 4 second. Now you come to here, give the animation, it stops for 4 second through PLC. So okay, because at S1 I have not interfaced the timer. I can put a one more timer because these are all soft timers. In a electro-pneumatic, hardware timers are required, but here the soft timers are required, so that always the PLC is better than any technology like electro-pneumatics and pneumatics. Okay, here freely available timers are freely available. Just you set the timing. Suppose you can set the timing 4 second here. Now you see that 4 second, and you see the red line, the supply is going. Now S2 is on, S1 is off. Okay, 4 second and 3 second. Suppose I can use a counter also. The previous program, whatever I showed, I'll show by counter. So this is how the PLC is working. So okay, if you double click, you can change you can write the program. So one ready-made program already open. Yesterday I made a PLC counter. Already this program I showed by electro-pneumatic. Okay, same PLC, S1 and S2 sensors, A plus and A minus are solenoid valves, but the programming part is this. Because this is a FBD, this software has a limitation. Because it is a freely downloaded software, no ladder programming. FBD, this is block. You see that AND gate, and is a counter. 3 is a counter. You can set 4. Okay, and NOT gate, and this is what the timer. Okay, so you can write a programming. Now you see here 1, 2, 3, 4. It's how many seconds I have given in the, you see in the programming, the counter are 4 and delay time is 3 seconds. Instead of 3 seconds, I can go for 4 seconds, and instead of 4 counting, I can go for 3 counting, and automatic resetting. Everything will be automatic through PLC. Okay, suppose dependent switch I can use. Okay, when this switch is on, the bulb should on. 24 volt bulb is required. Supply is required for switch, and this is the bulb. Output is a bulb instead of solenoid valve. Okay, I'll use the bulb. Suppose now it is not, bulb will be not on because I have not written the program properly. So I'll write the programming. I'll remove entire thing. Simple thing is, when I1 is on, input is on, output should be on. This is a programming. Now you see here, when input is on, output is on. Suppose if I have not written anything, it is the PLC is not working because you are not given any knowledge to the PLC. Now PLC is not doing anything, just it is taking an input, it is not giving any output. So that you have to give, otherwise the bulb should on. Whenever I'll on, the bulb should on after 3 seconds. You can give the on delay timer. So even I'll on the switch, the bulb should on after 3 seconds. So bulb should on after 3 seconds. Okay, just you see that. As soon as all are off, it will off because it's on delay. But it is whenever I'll make a on, it should on after 3 seconds because I have written in the program. On delay timer I have attached here. On delay timer I have attached here. Suppose off delay timer I can attach also. Off delay timer. Suppose off delay timer. Here there is a on delay. They have mentioned, and on off delay is also there. Off delay. They have mentioned off delay. Suppose off delay. Here you can where I'll give the input. Okay, just you or trial and error method. You can give the input. Okay. Suppose otherwise you can cross check here also. Okay. Suppose my input is by mistake. My input is here below. Then it is not working here. Then output is not on. So that you can change the input. You can see the simulation here also. Here also. The main simulation you can see here. As soon as I'll make a switch is on, it is on, but it is a off delay timer. Whenever I'll make a off, it should off after 3 seconds. You see here, the switch is off, but the bulb is off after 3 seconds. So this is the way to interface the PLC to the inputs and outputs. Okay, I have quickly I have completed my presentation.